Good afternoon, boys and girls. Welcome to another lesson on Technical Sciences, grade 12. It's the 26th of September. It's a Saturday, and we are having our question and answer session, and it is based on organic reactions. In other words, we are concluding this section of the work, and we've really dealt with it extensively, and we have done some questions. And to make this easier for you as well, my dear learners, we are continuing with more and more questions from previous examination papers so that you are well acquainted with how the questions are going to be asked and also how you should be able to approach the questions so that you get all the marks in that particular question. So, quickly on the outline of our lesson, we'll quickly just browse through what is expected of us as per the examination guidelines in terms of organic reactions, and we will learn these reactions basically through structured questions from previous examination papers, and I will also give you more tips on how to prepare this section of the work in preparation for your examination. Right, so basically, as per our examination guidelines, we've really talked about this extensively, my dear learners, is the different types of reactions. So it is our combustion reaction or an oxidation reaction for hydrocarbons. Then we looked at different types of addition reactions for alkenes, which is your hydrohalogylation, halogenation, hydration, as well as hydrogenation. And then we looked at reactions of haloalkanes, and in particular we looked at the substitution reaction, and also the type of substitution that we looked at here was hydrolysis. Then we went on to look at how alcohols can react with a hydrogen halide in order to produce an organic compound that belongs to the homologous series haloalkanes. And lastly, we also looked at substitution reactions that alkanes undergo, and in particular we looked at how does substitution occur when these alkanes react with halogens altogether. And more specifically, we dealt with bromine as well as chlorine altogether, chlorine gas, Cl2. So that is essentially what we looked at during the course of the week. And then we looked at another section on organic reactions as well, and this was on plastics and polymers. And we understand that we had to learn all these definitions as well: the definition of a macromolecule, the definition of a polymer, the definition of a monomer, the definition of polymerization, and the definition of a plastic. And furthermore, we learned how to identify monomers from given addition polymers. And in particular, we learned that the monomer here that we were dealing with, it's ethene, and the addition polymer that we're dealing with is polyethylene. And then we discussed the industrial uses of polyethylene. Now, most of these concepts here, as per the examination guidelines, we are going to get them as we learn our organic reactions, and therefore it will become easier as well as we continue. So now I want us to look at this particular question and see how best we can actually answer this question, and furthermore, how best we can actually use this question to learn and to revise the content that we learned throughout the week. So we are not just going to drive straight into questions, and we are simply going to look at this particular question, analyze it thoroughly, see if we can still remember our content, and then when we are done, we can go to the questions, and it will become easier for us because we would have done, in fact, everything that we need to do. Right, so they give us this information. They tell us butane can react with excess oxygen and, just getting my pen there, and is used as a cigarette lighter fuel or in bottled gas for cooking. Then we are required to write down the type of reaction that takes place when butane is used as a fuel. So firstly, we are required to write down the type of reaction. Now, if we are required to write down the type of reaction, we know we've got different types of reaction. We have combustion, which we also call oxidation. We have substitution. We have addition. We have polymerization altogether. So we need to be able to choose amongst those what type of reaction are we dealing with here, right? So, right, let's quickly remove that. Okay, right. So we are required to write down the type of reaction that takes place. Now, out of those that I have mentioned for you, which is your substitution reaction, your addition reaction, your combustion reaction, which we also call the oxidation reaction, as well as your polymerization, we need to choose which one is relevant. Now, because there we've been told that it can react with excess oxygen, we know that is when it is undergoing combustion. And to undergo combustion requires that excess oxygen. Furthermore, we are told that it is used as a cigarette lighter fuel or in bottled gas for cooking. Now we know when that is actually happening, then our butane is actually burning in the presence of oxygen gas when it is being used as a cigarette lighter fuel, or also when it is used for cooking, when bottled gases that contain bottles are used. As a result, we know the type of reaction there is called combustion. The type of reaction there is called combustion. Now, other learners could say, actually, if I don't want to say it is combustion, then I can say the type of reaction there is actually oxidation. Right, the type of reaction there is actually called oxidation. Right, so any of those, you are going to be awarded 1 mark. Then we are given more information. They say to us, consider the flow diagram below and answer the questions that follow. Now, this flow diagram here is based on organic reactions. It is based on interconversion of compounds between each other, from this compound to a different compound through various reactions of a compound to give you different products. And I told you again that you are very much likely to get a question on organic reactions in the form of a flow diagram. Now, if it is in the form of a flow diagram, what must I find out here? Remember, I told you that a flow diagram does not necessarily show you everything that takes place during a chemical reaction. There could be some reactants that are omitted. There could be some products that are omitted. There could be reaction conditions that are omitted. As a result, my dear learners, it becomes our duty to figure out what has been omitted and what has not been omitted. So we must check every time, are all the reactants shown? If yes, we are happy. If not, we figure out the other reactant. We then check out again, are all the products shown? If all the products are shown, we are happy. If not all of them are shown, my dear learners, it means that we have to figure out the other product, and we must also figure out the reaction conditions. So we start with the first one. Now, let us look at reaction 2 in particular. There I have a molecule, and this molecule, we can actually try and give it an IUPAC name, right? Now, if we want to give it an IUPAC name, then I'm first going to figure out the parent chain. In other words, the longest chain of carbon atoms that follow each other, that are bonded to each other without breaking. So I can see that I have 1, 2, 3, 4 carbons. So if I have 4 carbons already, it means my prefix is going to be a bute. Secondly, I then check, this is a hydrocarbon. So it is either an alkane or an alkene or an alkyne. But I see the double bond there, which is the functional group, the double bond between carbon and carbon atoms. So this automatically tells me that the molecule belongs to the homologous series alkenes. Now, if it belongs to alkenes, then I know that the name of the molecule has to end with an E. ENE rather. Then I then look at my carbons. Obviously now this is carbon 1, this is carbon 2, this is carbon 3, and this is carbon 4. So if I'm numbering from left to right, then the double bond is between carbon 2 and 3. So the lowest numbered carbon is then 2. Even if I were to number from right to left, and this would then be carbon 1, carbon 2, carbon 3, carbon 4, I will still get the same results. The double bond would still be between carbon 2 and 3. So the lowest numbered carbon is then 2. Then I show them the position of the double bond, and it is on carbon number 2. Then I put an ENE. Remember, my dear learners, when you show us the position of the double bond, which is a number, then you need to remember that you need to have a hyphen between a letter and a number. That is why I have it there. I also have a hyphen there between a letter and a number. So this molecule is butene. Then they show us that butene is actually reacting with hydrogen bromide. It is reacting with HBr. Now, what am I expecting there? Firstly, my dear learners, for your syllabus, I have told you that your alkenes will undergo addition reactions. If they undergo addition reactions, it means the double bond of this butene, it needs to break, because that's what I told you as also some sort of recipe for you to say, remember your alkenes at all material times, they will undergo addition. It means I am expecting the double bond to break between the second carbon as well as the third carbon. So how will I draw compound C? Compound C, it's still going to have 4 carbons. So it will be 1, 2, okay. Let me just write it a little bit lower. There we go. 1, 2, 3, 4 carbons. Now, can you see between carbon 2 and 3, this carbon and this carbon, I have broken the double bond. Why? Because butene is my reactant altogether, and it's reacting with HBr. The mere fact that butene is reacting, it means this is a reaction of an alkene, and we know for our syllabus, alkenes will definitely undergo addition. So the double bond breaks. Now, when the double bond has been broken, then I can see that what I initially had was this. I had on the first carbon an H, another H there, another H there. It is these 3 hydrogens. And then on carbon number 2, I still had an H. On carbon number 3, I still had an H. On carbon number 4, I had 3 hydrogens, 1, 2, 3. Right. Now we ask ourselves, we've broken the double bond and all the atoms were shown as before, but does the molecule look correct? We then check. On the first carbon, it has 1, 2, 3, 4 bonds. On the second carbon, it has 1, 2, 3 bonds, so we are short of 1 bond. On this carbon, we have 1, 2, 3 bonds, so we are short of 1 bond. On the fourth carbon, we have 1, 2, 3, 4 bonds. In other words, I am short of 1 bond there. I am short of 1 bond. And why am I short of 1 bond? Because I have broken that double bond there. And that is where we add our H on 1 carbon, and then we add our Br on another carbon. So we have added the H as well as the Br. So that is addition. If you break a double bond, you make 2 of these carbons to be short of 1 bond each, and hence we are going to add those bonds through adding a hydrogen atom as well as a bromine atom. Then we go and check if the reaction is balanced. So the number of carbons in the reactant is 1, 2, 3, 4. The number of carbons in the product, which is compound C, is 1, 2, 3, 4. The number of hydrogens is 1, 2, 3, 4, 5, 6, 7, 8, and 9 with that particular H. So I check here in the product as well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So the hydrogens are balanced. And then I go to the bromine atoms. I see that I have 1 bromine atom. I also have 1 bromine atom. So the reaction is also balanced. Then we go back to what I taught you. I said to you, when we deal with organic reactions, we actually need to remember 3 things. To say we need to show our reactants, and there we have shown them. We need to show our products, there we have shown it. And lastly, we need to show our conditions. Now, to figure out the conditions there, my dear learners, you actually have to figure out what type of a reaction is taking place first, and then we figure out that this type of reaction is an addition reaction. And we know why this is an addition reaction. Number one, in my reactant, I had a double bond, but the product doesn't have a double bond. So I have broken the double bond altogether. So that is addition. Secondly, on carbon 2, I only had one hydrogen. On carbon 3, I had one hydrogen. But now on carbon 2, right, I have a bromine. And then in addition to that original hydrogen, on carbon number 3, I have a hydrogen in addition to the original hydrogen altogether. In other words, I have added that H and I have added that Br. And the rest of the hydrogens were originally there. And that is why we say this reaction is an addition reaction. Furthermore, we can ask you, what type of an addition reaction is this one? So it means I've already figured out the type of reaction is addition. But now I am trying to figure out the type of addition. In other words, how have I added? Or what have I added? And I can see that I added the hydrogen there. I added the bromine atom. And we know a bromine atom is a halogen. In other words, the type of addition there is it's a hydro. Okay, that one doesn't look nice. It's a halogenation. Right, so the type of addition reaction then is a hydrohalogenation. Why hydrohalogenation? Because I added a hydrogen as well as a halogen and H as well as a Br. And I told you, you need to take good care of this one. It's not hydrogenation, halogenation. It's hydrohalogenation. Right. Lastly, we were actually just trying to work out the conditions. And we know that when we have hydrohalogenation, any form of addition that includes halogenation, we know that for our reaction conditions, we are going to require an inert solvent. And we know when you talk about an inert solvent, some of you could write it as an unreactive solvent altogether, my dear learners. So that is essentially that, and you must be able to remember all these conditions. Now, I want us to look at this other reaction which forms compound A. So what we see there is that we are having butene and it reacts with hydrogen gas. Automatically, my dear learners, we can see based on these arrows that this one is going to form that one, which is compound A. In other words, we can see that butene is going to form compound A. So it means butene is the reactant together with the hydrogen gas, and compound A is the product. So you must also be able to interpret the flow diagram such that you can actually determine which one is the reactant and which one is the product. So there's our reactants. Automatically, I know that the type of reaction that is going to take place here is going to be addition. How do I know that it is going to be addition? Because when alkenes react, the double bond breaks. And once the double bond has been broken, we know that the type of reaction becomes addition. Altogether, right? It becomes addition. So we know, my learners, that our alkenes will undergo a type of reaction that we call addition. Furthermore, my learners, when it undergoes addition, the double bond has been broken, and therefore these two carbons, which is carbon 2 and 3, will then be short of one bond each. And that is why one bond will be made up of this hydrogen, one hydrogen, and another hydrogen will be going to carbon number 3. In other words, when I see compound A, what I actually see is a molecule that still has 1, 2, 3, 4 carbons. It means I took this molecule and I see that it still has 4 carbons, but now the double bond has been broken between carbon 2 as well as carbon 3. What is left is for now to put what I had before. So on the first carbon, I had 3 hydrogens. There they are, 1, 2, 3. On the second carbon, originally I had 1 hydrogen. The third carbon, the same applies. I had 1 hydrogen. The fourth carbon, which is this one, I had 3 hydrogens. 1, 2, 3. Now, does this molecule look correct? And we say, no, it doesn't. Why? Because I have broken the double bond there. So this carbon is short of 1 bond, and this carbon is short of 1 bond. So what am I going to bond there? I am going to bond these hydrogen atoms. So it's 2 hydrogen atoms. So 1 hydrogen atom will go there and 1 hydrogen atom will go there. Altogether, my dear learners, as a result, then this molecule looks correct. So let us just check for balancing. How many carbons do I have in the reactants? I have 1, 2, 3, 4. As well as in the product, I have 1, 2, 3, 4. The hydrogens in the reactants, I have 1, 2, 3, 4, 5, 6, 7, 8. Plus this 2, it will make it 10. Then here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Altogether, my learners, as a result, I can see that it is balanced. Then I want us to work out what the conditions, because we are done with the reactants and products. But it will always help a great deal if you want to work out the conditions by first realizing what type of addition this one is. So we can see that I've added those 2 hydrogens there because they were not there on carbon 2 and 3. So because I added 2 hydrogen atoms, then the type of addition shows that I have added hydrogens. So we will say it is hydrogenation. Right, so the type of addition there, right, the type of addition is then called hydrogenation. Right, and remember, we don't say it is hydrogenating. We say it is hydrogenation. So why hydrogenation? Because I've added the 2 hydrogen atoms there. So the type of addition reaction is then called hydrogenation. Then to remember the conditions, remember hydrogenation requires either platinum as a catalyst, or you can use palladium as a catalyst, or you can use nickel as a catalyst. And remember what I also said to you, my dear learners, you need to write them either on top of the arrow or just beneath the arrow. And you write them with their correct chemical symbols, taking into consideration that the first letters are capital letters, and then those that follow will be small letters. So you don't really have to write all three. You can write any of those conditions. And we know that the function of platinum there, it actually acts as a catalyst altogether. Good. Now, let us go to reaction 1. Reaction 1 requires that we look at compound C being a reactant, and it is going to form an alcohol. Now, compound C, we have actually worked out its structural formula. There it is. And if you look at compound C, my dear learners, you can actually say to me, Meneer, this compound is a secondary haloalkane. Why is it a secondary haloalkane? Let us start. Firstly, it is a haloalkane because it has carbons and hydrogens. So it is an alkane somehow because it is a hydrocarbon with single bonds between carbon and carbon atoms. But there we also have a bromine atom, which is a halogen. So as a result, this molecule, we don't say it belongs to alkanes. We say instead it belongs to haloalkanes. Now, why is it a secondary? Because the carbon that is carrying the bromine, in other words, this carbon that is carrying the halogen is bonded to this carbon, and it is bonded to that carbon. So the carbon that is carrying the halogen is bonded to two other carbon atoms, and that is what makes it a secondary alcohol. Now, a secondary haloalkane. Now, if this secondary haloalkane forms a secondary alcohol, then I know that when I have a secondary alcohol, it means that I'm going to have the carbon that is now carrying the hydroxyl group being bonded to two other carbon atoms. Now, let us look at this molecule and see how can this secondary haloalkane, which by the way we call it 2, right? 2-bromo-butane. And I'm not really teaching you nomenclature for now. I'm sure you already know how to work this out. We've done our nomenclature extensively. So this is simply 2-bromobutane. So if it is going to form a secondary alcohol, then I'm expecting that alcohol to actually be butan 2-all. How? It means I'm going to have this 4 carbons still. Remember, the reaction has to be balanced. So the number of carbon atoms on the left must be equal to the number of carbon atoms on the right-hand side. Then it's a secondary alcohol. For it to be a secondary alcohol, my dear learners, it tells me that if I number from right to left, then this will be my carbon 2, and it must have a hydroxyl group. Altogether, it needs to have a hydroxyl group. I just wanted to look nicer. Okay. butan 2-ol. So firstly, it forms an alcohol. So I know that I must have an OH, which is alcohol. Then it means this hydroxyl group has to be on carbon number 2. Why? Because the carbon that is carrying the hydroxyl group must be bonded to 2 other carbon atoms. So it will be bonded to that carbon atom altogether. Then what do we note, my dear learners? It means each carbon must also have 4 bonds. So because this one had 1, so I'm going to put 3 bonds, which are the 3 hydrogens. Then, so I will put hydrogen there. Then this carbon, it is short of 1. I'm going to put a hydrogen. This carbon is short of 1. I'm going to put a hydrogen. This carbon is short of 1. Rather, it was 3. So I can see now the transformation, it's actually from having a Br on carbon number 2 to having an OH on carbon number 2. And it was all hydrogens except on carbon 2 where it was a Br. So what type of reaction has actually taken place here? The type of reaction that has taken place here, substituted with the OH. So I'm expecting that the type of reaction there is definitely substitution. Why? Because I removed the Br, but I didn't just remove it. I put something else and I put a hydroxyl group. So the type of reaction is substitution. Now, let us remember now to say, okay, Meneer, we are happy with this, but now is our reaction actually balanced? And the truth of the matter is that it is not balanced. We then check, there is no way that this Br can magically change and become OH. It means there must have been another reactant that is reacting here altogether. So another reactant that must have been reacting here with compound C, it's most probably H2O. So it could be H as well as H bonded to OH. And we know this means water. So when it is water altogether, and I want you to hear me clearly on this one because there are 2 possibilities actually here. If I have H and OH, it means this OH is the one that went to carbon 2 to substitute the Br, and hence it is there. So what am I going to be left with if this and that react with each other? I'm going to take the OH and put it there, and hence I form that. So I'm going to be left with this hydrogen that I did not, the Br right here, it must be H, which is this one that I did not use, and the Br that I have removed. So another product there is going to be HBr. Now, my dear learners, this one normally, it requires that you actually go to the question and check, because we could still have used a dilute strong base, NaOH. And if I used NaOH, which is dilute sodium hydroxide, so it's a dilute strong base, the OH will still bond there, and then I'm going to be left with the Na that did not work and the Br that I have substituted. So it would be plus NaBr. So if I used HOH, then I'm going to form HBr. But if I used NaOH, then I would have formed NaBr. Whether substitution took place through that dilute strong base or simply through water. Now, if it was through water, we could have asked you further to say what type of a substitution is hydrolysis. And why would you say this is hydrolysis? Because we did our substitution using water altogether. And still hydrolysis is a reaction of a substance with water. So this is essentially that altogether. So we then remind ourselves that, okay, if we want substitution of haloalkanes, because these are our reactants, then we need to make sure that we provide heat, but that heat must be mild. So it must be very clear that the heat that you are dealing with here must be mild heat. And you also require excess water and dilute strong base. So those are the reaction conditions that must be met in order for haloalkanes to undergo substitution. And definitely our reaction is also balanced. How do we know that it is balanced? Because the number of carbons on the left is equal to the number of carbons on the right. The same applies to hydrogens and the same applies to bromine atoms altogether. So we can see that again, there's an inorganic reactant that they did not show us, which is that one. Or depending on the question, it could be sodium hydroxide. And the organic product, it's HBr because we formed it. Or if we had used NaOH, then it would be NaBr, and that is another product that is formed, but it is inorganic. This one, butan-2-ol-N, it is an organic reactant, right? So I can tell you, after we have done this, my dear learners, it means we can ask, and rather we can answer any question that is given to us. Let us go through them. We are required to write down the name or the type of the following: reaction 1 as well as reaction 2. Then we agree for reaction 1, it is definitely substitution because the Br on carbon 2 was substituted by the OH. And then for reaction 2, we saw that butene's double bond was broken, was there in the reactant, it's not there in the product, so it's addition. And also we added an H there and a Br, there they are. So reaction 1, it's substitution. Reaction 2, it's addition. So therefore reaction 1, we will indicate that it is substitution. Substitution. Then agree that reaction 2 is definitely addition. Right. So that is how our marks are allocated. 1 mark there, 1 mark there. Easy stuff. Then we are required to write down the name of the following: compound A, alcohol B, and compound C. Compound A, there we can see it. It has 4 bonds, rather 4 carbon atoms. So it is a bute. It is a hydrocarbon, single bonds between carbon and carbon atoms. So it is an alkane. So the name must end with ANE. Then that's butane. Then we were also asked for alcohol B. And alcohol B, we agreed that it is butan-2-ol. Why bute? Because it has 1 2, 3, 4 carbons. So there's the but. And remember, you must add the AN, so it's butan. Then it has the OH, so it's an alcohol, the name ends with ol. Then we number our carbons from right to left. Why right to left? Because when I number 1, 2, then the functional group, which is the hydroxyl group, becomes on carbon number 2. But if I number from left to right, it would have been 1, 2, 3. So the hydroxyl group would be on carbon 3. And that is not in accordance with what? Because the IUPAC rules tells me that the hydroxyl group must be on the lowest numbered carbon, which is carbon number 2. So that is why there I will put a 2. The name begins with butan. The name ends with also right in the middle of what it begins with and what it ends with. I will put the position of the functional group, and then I will have a hyphen in between because it's a letter and a number. It's a letter and a number. So this is butan 2-ol. Then for compound C, I told you it's 2-bromobutane. Why? Let's start with the parent chain. The parent chain, it's 1, 2, 3, 4 carbons. So it's a but. This looks like an alkane because it's a hydrocarbon, but there's also a halogen, so it's a haloalkane. So the name ends with ANE. So we are done with the parent chain. Then I can see that the bromine is on carbon number 2. Why? Because I'm numbering from right to left. So if it is on carbon number 2, then I know that I'm going to have a bromo and it's on carbon 2. So I will indicate the position of the halogen and I will put a hyphen because I must have a hyphen between a letter and a number. So the order, compound A, it's butane, alcohol B, butan 2-ol, compound C, 2-bromobutane. So compound A, we agreed that this is butane. And can you see, my dear learners, you are just going to get 2 marks for that. So the examiner actually likes us, giving us a lot of marks there. Alcohol B, we agreed that it is going to be butan 2-ol. Butan 2-ol. That is also another 2 marks. Then compound C, we agree that that one will be 2-bromobutane. And we are also getting 2 marks. Now, what I want you to be wary of, my dear learners, is that if you make a mistake there, meaning you leave out a hyphen between a letter and a number, or you leave out that AN and so on, you are going to forfeit marks altogether. Or there you put a hyphen between a letter and a letter, you are going to forfeit marks because that is not in accordance with IUPAC rules altogether. Right, then we go to 4.4. We are required to then name one reaction condition for reaction 1 altogether. So if you want reaction conditions here, remember those are then reaction conditions of haloalkanes. And our haloalkanes undergo substitution. And we know for them to undergo substitution, we require mild heat, and they were very nice to us because they are actually requesting for 1. So it must be mild heat. Now, this is NB. That mild there must be shown altogether. It must be shown. If you just say heat, then it is incorrect. The heat has to be mild altogether because the heat being mild actually has a favor substitution. But if the heat was high, then it would favor what we call elimination, which is anyway what you do not do for your syllabus. Then we know that you require excess water. So you definitely require excess water, right? So these are also recall questions, my learners. You have to remember them off by head, right? Excess water. And another one that you could have included there is to say we require a dilute strong base. Remember, if you just say strong base, we don't give you a mark altogether, because the fact that it is dilute, it's actually why it would favor substitution altogether. So it definitely has to be a dilute strong base altogether. Because if it was concentrated, then it would actually favor elimination. And as I've mentioned, it's not what you are working with in your technical sciences syllabus. So there, we require a dilute strong base. So those are also amongst the errors that you as learners make. You then write heat instead of mild heat. You would write water instead of excess water. You would write strong base instead of dilute strong base. So please write them exactly as they are. Sometimes you then say dilute base, so you need to correct that altogether. It's a dilute strong base, right? So what have we learned here, my dear learners? We have actually revised some of these organic reactions that we dealt with throughout the week. Secondly, my dear learners, what is happening here is that we were able to answer everything based on what we have made on our flow diagram. So the lesson here is when you practice these questions, do everything, because you're not going to get the same flow diagram. So you actually want to check if you remember how to work with this. So we move to the next question. In this question, we can see again it's on organic reactions, and again it is a flow diagram. Now it reads as follows. The flow diagram below shows some of the reactions of propene. So there we have propene, and the sheen undergoes. Again, I will emphasize this to you, my learners. You have to make sure that you figure out what has not been shown in the flow diagram, which should actually be there, which should actually form part of the reactions. So I want us to look at all these particular reactions. And I want us to start with propene reacting with a particular molecule to form C3H8. So before we start, let us draw the structural formula of propene. We know prop means 3 carbons. So I'm going to have 1, 2, 3 all together. Then if it's propene and there is no position indicated there, it definitely tells me that the double bond must be between carbon and carbon atoms. It must be present, and it must be on carbon number 1. So there I'm going to put a double bond, because obviously now the name ends with ENE, so the molecule belongs to alkenes. Then I'm just going to check again that because it's an alkene, it's a hydrocarbon, so it must only contain atoms. So around each carbon atom, remember, I need to have how many bonds? 4. So I already have 2 here. So this will then be 3. And this one will be the 4th one. Then carbon number 2 has the fourth one with the hydrogen. Carbon number 3 has 1. So it is short of 3. So I'm going to make 1, 2, 3, and I'm going to put my hydropropene. Now, let us look at reaction B. Reaction B, they show me that propene reacts, so it is a reactant, and it forms C3H8. So let us first look at C3H8. So what has been given formula? It's going to have 3 carbon atoms, and then the hydrogens must be 8. Now, because it's an alkene reacting to form something, I know it will be an addition reaction, so the double bond must break because an alkene is reacting. And that is why I showed you single bonds between carbon and carbon atoms. Then if I check my hydrogens, it will be 1, 2, 3, 4, 5, 6, 7, 8. And each carbon there, I can see that it has 4 bonds. Right, in other words, this particular propene was turned into an alkane. Why is it an alkane? Because it is a hydrocarbon, and I'm getting single bonds between carbon and carbon atoms. So definitely this particular molecule that was formed, it has 3 carbons. So it begins with prop, and it is an alkane, so the name ends with ANE. In other words, propene has been converted to propane. Now we check what has really happened. Can you see that on carbon number 1, when you started, you had 2 hydrogens. But now on carbon number 1, how many hydrogens do we have? We have 3. It means I have added that hydrogen there. On carbon number 2, I had 1 hydrogen. But now on carbon number 2, I have 2 hydrogens, and I have added that hydrogen there. So this already, my dear learners, it is telling me that I have added 2 hydrogen propane. In other words, there is another molecule that was not shown, and that must have been plus, it must have been H2. So it's propane plus hydrogen gas, and it gives me propane. Then we check if it is balanced. So I have 1, 2, 3 carbons, 1, 2, 3 carbons, hydrogens, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So the reaction is balanced altogether. What else must I talk about? I have shown you my reactants, which is propane and hydrogen gas. I have shown you my product there, which is propane. So I'm just left with conditions. And remember, it's easy to remember conditions when you have actually worked out the type of reaction, and if it is addition, exactly the type of addition. So firstly, I know that this type of reaction is addition. And the type of addition specifically, I see I added 2 hydrogen atoms there, right? I added hydrogen gas. In other words, the type of addition there, because of adding hydrogen gas, we then call it hydrogenation. Right, so the type of addition there is called hydrogen. When the type of addition is hydrogenation, then either we can use platinum as a catalyst, or we can use palladium as a catalyst, or we can use nickel as a catalyst. Nicely for you, right? And as I have mentioned before, you don't need to show all three. Any of those is a suitable catalyst. So we are done with reactants, conditions, and products based on reaction B. So I want us to look at reaction C. So when we have reaction C, you see, I'm starting with those that are quite easy, so that I'm able to also boost my confidence, if I were to be in an examination room. So there I have propene and it reacts with HBr. So when we see that, we are very happy. Why? Because we've been given the other reactant and we know this is an inorganic reactant. Then when propene reacts with HBr, it's definitely a reaction of an alkene. So if an alkene is reacting, we know the type of reaction that it will undergo is definitely addition reaction altogether. So if the type of reaction is addition reaction, then we say, okay, it means the double bond is going to break. So when the double bond breaks, it means I will still have 3 carbons of propene, which is 1, 2, 3. And then I have broken the double bond on carbon 1 and 2, which is basically on the lowest numbered carbon, which is carbon 1. Then I'm going to put those original hydrogens that I had. So originally I had 2 carbons there, 1, 2. There I had 1 hydrogen atom. There I had 3 hydrogen atoms altogether. Then I'm going to then see that I am short of 1 bond on this carbon because it already has 3. I'm also short of 1 bond on this carbon because it already has 3. So I'm going to put an H there and I'm going to put a Br there. Why? Because they are there. They are reacting with the propene. Then it means I have 2 reactants there, which is my propene organic and HBr rather, which is inorganic. And I'm going to form that particular product. And this product, I can see the longest chain without breaking its prop because it's 3 carbons. And this molecule is a haloalkane because of that Br. So it will end with ANE. Then if I number from left to right, the bromine will be on carbon 2. If I number from right to left, the bromine will be on carbon 2. So the lowest numbered carbon that this bromine can be at is carbon 2. So I'm going to indicate there I have a bromo and I will indicate it's on carbon 2. And then between a letter and a number, I know that I have to put a hyphen. So this is 2-bromo-propane. And the reaction is balanced. Then I check what type of a reaction is this. Then my learners are definitely saying to me, Menier, it's an alkene that is reacting, so it's none other than addition. Or why, Menier? Because I had a double bond here in my reactant, but in my products, the double bond was broken. So that is definitely addition. Furthermore, say, you see, that Br was not there. So I've added the Br. That H was not here. So I added an H. And that is why we say this type of reaction is addition. And then another learner could say to me, Menier, what type of addition is this one? Then the learner sees that I've added a hydrogen and a bromine atom. In other words, I added a hydrogen and a halogen altogether. So if I added a hydrogen and a halogen, then the type of addition must be hydrohalogenation. Right, this must be hydrohalogenation. Right, then we've talked quite extensively that it must be hydrohalogenation. Right, then is it balanced? Yes, 3 carbons on the left, 3 carbons on the right. Right, basically 3 carbons in the reactants, 3 carbons in the products. Hydrogens 1, 2, 3, 4, 5, 6, 7 with this one. Then here I have 1, 2, 3, 4, 5, 6, 7. Good. Then the hydrogens are balanced. Then for the bromine atoms, I have 1 bromine atom there. I have 1 bromine atom there. So our reaction is chemically balanced altogether. So everything is correct. We know the reactants, the products, the type of reaction, the type of addition reaction, as well as the conditions. Then we are going to look at reaction D. When we look at reaction D, we can see that propene is being turned into an alcohol, or simply compound X is being turned into an alcohol, but that is then through reaction E. So to make it easy for you, my dear learners, we can just look at the reaction D. So propene turning into an alcohol tells me that whatever I'm going to form, which is this alcohol, will still be an alcohol that has 3 carbon atoms. One, two, there we go. It has 3 carbon atoms. Then I know that definitely for a propene to form an alcohol, the double bond is going to break, and hence I've shown you single bonds between carbon and carbon atoms. And if it is going to be an alcohol, it means I'm going to require a hydroxyl group. And where am I going to get a hydroxyl group? We know that a hydroxyl group, we are going to get it on a water molecule. And that water molecule, to make it easy for ourselves, we will then show it as HOH. So it's still 2 hydrogens, so it's H2O. So this shows me that, oh, this is where the hydroxyl group, which is in the alcohol, is coming from altogether. So I have my 3 carbon atoms there, and remember, I had a hydrogen there, I had a hydrogen there. There I have 2 hydrogens. On this carbon, I also have another hydrogen. On this carbon, I have how many hydrogens? 3 hydrogens altogether. Now, what is the problem? This double bond. Then this carbon is missing one. I'm missing 1 bond, and there I can see I am missing 1 bond. And that's where the H and the OH are going to bond. And there I'm going to have an H, and there I'm going to have an OH. Altogether, carbon atoms, it's 3 on the reactants, 3 in the products. Hydrogens, 1, 2, 3, 4, 5, 6, 7 with this one. 1, 2, 3, 4, 5, 6, 7 with this one, then I have an OH, then I have an OH. Right, so it is balanced. So can you see there's another, is definitely a water molecule. Right, and there's our product. Now, we then ask ourselves about the conditions. But remember, for us to know the conditions, it becomes a little bit easier if we know the type of reaction and the, particularly which is addition here, the type of addition. So this is an addition reaction. Why say? Because the reactant had a double bond between carbon and carbon atoms, but now the double bond has been broken. Furthermore, I added that H there. This carbon, say it had one hydrogen, but then the carbon has a hydrogen as well as an OH. So I added a hydroxyl group there. So this is definitely addition. Then we ask, are we dealing with? We say, okay, I added a water molecule. Similar to drinking water, if I drink water, I'm hydrating myself. So if we are adding water molecule, it means the type of addition is what we refer to as hydration altogether. So that is essentially what we are going to form. And we can ask you again, what is the name of that molecule? Then I can see it has 3 carbons. So it's prop. And then we add the AN, so it's propan. If I number from left to right, the functional group, which is the hydroxyl group, will be on carbon 2. If I number from right to left, then it will still be on carbon 2. So it will be propan 2. And because it's an alcohol, the name ends with OL. So the name of this alcohol is then called propan 2-ol. Right. Then I want us to look at reaction E. Okay, before we finish with the reaction D, remember I said our code at all material times RCP, right? In other words, it's reactants, it is conditions, and it is products altogether. So we dealt with reactants, we dealt with products, now we must deal with conditions. And remember I said to you, when you form an alcohol, you will always require heat, and you will require sulfuric acid, which is H2SO4. And we know the function of H2SO4 is that it acts as a catalyst. Right. Then we look at reaction E. Reaction E, definitely, I have, and it is going to form propan 2-ol altogether. So we can see that this is the reaction of a haloalkane. And this haloalkane is being converted into this haloalkane is being converted into propan. The reaction actually took place there. I can see everything's the same. 3 carbons, hydrogens everywhere there, and a Br. 3 carbons, hydrogen everywhere there, but an OH. So this OH is actually now in place of where the Br was. So this automatically tells me that the Br has been substituted by a hydroxyl group. So the type of reaction there is definitely substitution. Are we together? So now we ask ourselves, where does that OH come from? And this is what reminds me that I still have those two possibilities. The OH there could be coming from OH, which is your water molecule altogether. So the OH went there and it replaced the Br. It substituted the Br. In other words, for this reaction now, it's going to be left with an H that I did not use and the Br that I removed. So I'm expecting that the other product for reaction E would have been HBr. And again, using a dilute strong base, which is NaOH altogether. And the NaOH will still perform the same function there to give that OH, which will substitute the Br. So if I used a dilute strong base, then it means the OH will still substitute there. Then I'll be left with the Na and the Br. Then this HBr would then have been NaBr. But whether they used the water molecule to perform this substitution or they use that dilute strong base to perform the substitution. But we know if they have used this water molecule to substitute the Br there, then we know then the type of substitution would still be hydrolysis, because the organic molecule reacted with water altogether. You are going to require mild heat. So the heat definitely has to be mild altogether. And your excess water dilutes strong base and so on. Then lastly, I want us to look at reaction A. When you look at reaction A, right, I think I'll take a green one. Okay, no, it's nice. It still shows clearly. So A, we are taking this molecule and this molecule is forming that one. So this is an alkane that is reacting and it is forming a haloalkane. Transformation for reaction A from this to that. Clearly, the H there, this hydrogen there, has been substituted by a Br there altogether, and everything else is the same in terms of hydrogens. So definitely it tells me that reaction A is a substitution reaction. So this is definitely a substitution reaction. Then we substituted with a bromine atom. In other words, there is another one that they haven't shown us, and that must be bromine. But is it one bromine atom? No, my dear learners. Remember, bromine is diatomic, so it must have been Br2. And that was not shown. That is the other inorganic reactant that is needed. So when the Br, we just take one atom because we are substituting one atom at a time, then it tells me that I'm going to be left with one bromine atom and I'm going to be left with that hydrogen atom that I have removed. It means in my product for reaction A, which is green, I'm going to have another organic product, which is HBr. So now we have analyzed, my dear learners, the entire diagram. So what is left is to go straight to questions and you will see that we have all the answers, right? So let us do that. We are asked to write down what type of addition reaction is represented by each of the following letters. So they are asking for the type of addition reaction. It means we already know that those reactions are addition reactions. We just want to know what type of addition reactions they are. So B, we check. This one, it's hydrogenation because we added those two hydrogens. D, it's hydration because we added water molecule, the H and the OH. They asked us for B, D, and C. So C is definitely hydrohalogenation because we added an H as well as a Br. So when we just write it down there for B, we noted that it is hydrogenation. And then for D, we noted that it is hydration. And then for C, we noted that it is hydrohalogenation. Right, easy stuff. We just went to spot the answers. And C3H, write down a balanced equation for the combustion of C3H8 in excess oxygen. Remember, my dear learners, there it's actually not compulsory for the examiner to give you in telling you that it is combustion. Then you know that as we have learned it with ours, we deal with combustion where a hydrocarbon is reacting in excess oxygen. We get marks there. Remember, the equation must also be balanced altogether. So we'll start with the reactants. It means my reactants are C3H8, and you know we'll use a molecular formula, and it reacts with oxygen gas. So the first mark, my dear learners, is for reactants. And remember, it's not O, it is O2. And if it's in excess oxygen, then we will form water, which is H2O. Then the next mark will be for the products, and the last mark will be for balancing. And remember what I said to you, always start with the carbons and then the hydrogens and then the oxygens. Then we check how many carbons on the left. We have 3 altogether. How many carbons on the right? We have 1. So I can see that I am short on the right hand side, so I'm going to balance there with a 3. Then I'm going to check my hydrogens. On the left, I have 8. On the right, I have 2. So to make this an 8, I'm going to balance there with a 4. Why? Because 4 multiplied by 2 is going to give me 8. Then I look at my oxygens. Then the hydrogens are balanced. Then I look at the oxygens. I see that on the left-hand side, I have 2. On the right-hand side, I have 3 multiplied by 2, which is 6. Plus, I have 4. Okay, that doesn't look neat. So we started there by saying for oxygens I have 3, and I will multiply by the 2 on the oxygen. That will give me 6. Plus, I have 4 multiplied by, next to the oxygen, I have that invisible 1. So it's 6 plus 4, and that is going to give me 10 oxygens on the right-hand side. But on the left-hand side, I have 2. So to balance this, I'm going to put there a 5. Why? Because 5 multiplied by 2 is 10. Then I will get the third mark altogether. So can you see we have already 6 marks of the easy stuff. Then we are asked to write down the name of compound X. We don't even have to work it out, my dear learners. We have done that already, and we agreed that it is 2-bromopropane. 2-bromopropane. One mark there is for the parent chain, and 1 mark is for the functional group, including its position. Right. Then we must consider reaction E, and we must name the type. So when we go to E, okay, and we must also give 2 reaction conditions necessary for the reaction E to take place. So E, we saw that it is substitution. Why? Because where it was a Br, in the reactant, it is now an OH, so that was substitution. Now, what are the conditions that are haloalkanes? Mild, we will need a strong base, which is dilute, and we can also have excess water altogether. So there, the 2 reaction conditions that we can simply talk about there is what we call excess water. And you see, I'm not just writing water, my dear learners, I'm writing excess water. Secondly, another learner could have said a dilute strong base. You see, I'm not saying a dilute base, I am specifying it's dilute and a strong base. And I'm also not just saying strong base because it has to be dilute as well. So a dilute strong base, again, I'm going to require mild heat. And you can see that I'm not just writing heat, I'm writing mild heat because the mild is actually very important. So any of those 3 conditions, rather any of those 2 conditions will give you 2 marks altogether. So we'll mark the first 2 obviously. And the type of reaction there, we agreed that it is, okay. The type of reaction there, we have agreed that it is substitution. Substitution. That is going to carry 1 mark altogether. Let us move to the next one. Polyethylene is an example of a polymer typically used to manufacture plastic. The structural formula of polyethylene is shown below. So there we have polyethylene, right? Not so nice there because it must actually be like this one. In fact, let me do this. There we go. Right. Then they tell us this is the structural formula of polyethylene, and we definitely agree with that. It is polyethylene. It's a polymer. We can see the chain can grow longer into the left because it's a very large molecule. It is a polymer. Then we are required to define the term plastic. Now, plastic by definition, we say it is synthetic from organic compounds. Synthetic materials derived from organic compounds. Right. Right. So we check there. Plastics, those are synthetic materials derived from organic compounds. And remember, everything has to be there for you to get your 2 marks. Right. So those are synthetic materials derived from organic compounds. Then they tell us, name the monomer used to form polyethylene. Now, polyethylene in itself, it's a polymer. That is why the name starts with poly, right? There I must actually have an E. It's polyethylene. It's polyethylene, right? It's a polymer. Secondly, if it's a polymer and it's polyethylene, literally just translating it or putting it somewhat differently, it's many ethenes. In other words, there are a lot of ethenes, billions and trillions of those that are covalently bonding to each other in a repeating pattern. So it's many ethenes. In other words, I have a lot of ethenes there, which are my monomers altogether, because they are the ones that are joining covalently to each other in a repeating pattern. So our answer there is going to be ethene. So the monomer is ethene and the polymer is polyethylene. And then we are required to give one use or to name one use of polyethylene. And I said to you, it is used to make plastic products such as plastic bottles. That's number one. Or secondly, you can just say it is used to make bulletproof. Accepted. It is used to make plastic products like plastic bottles. And secondly, it is used to make bulletproof vests altogether. Right. Now, my dear learners, I've already given you the skill here, right? In terms of how you look at flow diagrams. So for this last question, we are not going to go deeper into really analyzing it again. You must be able to do that by now. I want us to move directly into questions. But when you practice and you do the questions, the flow diagram, you analyze it, and then you answer questions. But for now, I also want to see how fast we can work these questions to just analyze at all times. So it reads as follows. The flow diagram illustrates some of the reactions that pen 2-in undergoes. So here I have pen 2-in and it undergoes different types of reactions, which is A, B, C, D, and E. And we are required to use the information in the flow diagram to answer the questions that follow. Right? We are required takes place at A, C, and D. So they are types of addition reactions. So it means either it is hydrogenation, hydrohalogenation, hydration, and what is the last one? Halogenation, right? I'll repeat them. Hydrogenation or hydration, any of those four. So it was for AC and in, it's forming pentane. In other words, definitely addition. And what did I add there? You must be able to see that I have definitely added an H2, because where I will be going to add the 2 hydrogens. So pen 2-in looks like this. It's 1, 2, 3, 4, 5 carbons, pent, double bond, yes, on carbon 2. So it's 1, 2, right? Then I will put my hydrogens, right? We know this by now. So for A, and each carbon here, it has 4 bonds. So they are showing that it forms pentane, which is 1, 2, 3, 4, 5. Then hydrogens to make sure that each carbon has 4 bonds. Right. So let us check how many carbons? 5. 5 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just fix it there. 10 with this one. Now it's correct. But how many now? 1, 2, 3. Okay, let me start it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why 12? Because of these 2 hydrogens that adds to the 10 that is already there. And that is why we're saying for A, it is hydrogenation. For C, if you take pentane and you react it with water, you are going to add a water molecule. So that is going to be hydration altogether. Then we look at D. By just adding water to an alkene molecule, it's definitely addition, and the type of addition is adding water means hydration. Then we go from pentane to 2-bromopentane. So 2-bromopentane looks like this. 4, 5 carbons. Why 5? Pent. Then on carbon number 2, I am definitely told that I have a bromine atom. So it means the rest are going to be hydrogens. Right. So if you check there, you'll remember I had 10 hydrogens. Now I have 1, 2, 3, 4 hydrogens and a Br. In other words, I added an H and I also added a Br altogether, my dear learners. So that H there was not there, it was added. That Br was not there, it was added. So the type of addition there must be hydrohalogenation, because I added the hydrogen and the A. We agreed it's hydrogenation. Hydrogenation. And then C, we agree that it is hydration. And D is definitely hydrohalogenation. Okay, halogenation. Good. Then we must name the type of reaction that takes place at E. So if you look at E, you take pentane, you change it, and it forms 2-bromopentane. If it forms 2-bromopentane, what you should see is that when it was still a reactant, there it was a hydrogen. When it is a product, it is a Br. It means this hydrogen has been replaced or has been substituted by a bromine atom. So the type of reaction there must be substitution. And I must remind you again, my dear learners, and I think I didn't do that in the previous question. But remember, my dear learners, for haloalkanes to undergo substitution, remember they have this stable single bond between carbon and carbon atoms, so they don't react easily. And hence, we ensure that we provide heat and ensure that the reaction occurs under high pressure altogether, right? Or sunlight and high pressure, or what we call UV radiation and high pressure. Right. Then, which B can take place? Let us look at reaction B altogether. So in reaction B, 2-bromopentane is actually going to pentuene. Now, this one, my dear learners, it's really not part of your syllabus altogether. And that is actually 4.3 as well as 4.6. They are not really in your syllabus, so I really wouldn't want to go through all of those with you, but I really wanted to do this question with you guys so that other things that we work with are reaction T. Then in question 4.4, we are required to write down a balanced chemical equation for the reaction D using structural formula. Right, reaction D using structural formula, my dear learners, very simple. We can see it's pentuene forming 2-bromopentane. So I will start by saying pentuene. This is reaction D. Pentuene, it's 1, 2, 3, 4, 5. Double bond on carbon 2. Right, this I've already shown you. Right, make sure each carbon has 4 bonds. Oopsie. Right. We've already drawn it, ne? So there I'm just rewriting it. And they told us it forms 2-bromopentane. And we've already drawn that. Pent means 5. Then I have a bromine on carbon 2. That's if you number from left to right. Right, so this was pentuene and it formed 2-bromopentane. So I've added that Br there, but please don't circle it. And I've added that H there because they were not there. In other words, the other reactant that was not shown there, it must have been HBr altogether. Then if it was HBr, then I know it is addition, and the type of addition for D we said it's hydrohalogenation. In other words, I also need to show my inert solvent as the reaction condition altogether, right? And that is how you're going to get your full marks, 4 marks. Can you see the HBr was not shown and the inert solvent was not shown? So that is how you will get your 4 marks. And lastly, we must write the name or symbol for the catalyst used. We agreed it is hydrogenation. So if it is hydrogenation, remember what we need, either the name or the symbol. So if I wanted the symbol is palladium or it is nickel altogether. If I wanted the name, you would have written platinum, or you would have written, or you would have said it is nickel. Right, so any of those would be acceptable because they said the name of. Just to revert back to question 4.4, remember they said you must write the balanced chemical equation for reaction D and you must use the structural formula. And that's exactly what we have done. And you can go and in the reactants, it's exactly equal to those in the products altogether. And we won't really be dealing with 4.6. Because it requires condensed structural formulas and so on. But compound X, it's hydration, and definitely what I would have formed is an alcohol molecule, to put it simply for you. So you don't really have to deal with the rest of how this product is going to form and so on in terms of condensed structural formula. So that brings me to the end of the lesson. Remember, for those dynamic reactions, it's plus minus 29 marks. And as I've said to you, make sure that when you read your questions and your flow diagrams, you can interpret them and you make sure that you make notes because this must be a learning process. Right. So thank you very much. I will see you on Monday when we deal with physical properties of organic compounds. Thank you very much and enjoy the rest of the afternoon. Goodbye.